Hi, in this video we will discuss various trigonometric functions. So primarily we have 6 trigonometrical functions and they are called 1 sine theta, 2nd cos theta, the 3rd tan theta, 4th cot theta, 5th sec theta and the last cosec theta. So we have these 6 trigonometrical relationship, and now in context of a right triangle we will understand that how can we calculate the value of each of these trigonometrical function if we have the sides of a triangle. So here I am quickly drawing a triangle, a right triangle which has 3 vertices called A, B and C, and the triangle is right angle at point B. Let's assume that we are marking angle theta for this particular discussion as the angle C. Now if this is the theta, then we can understand that the side opposite to theta is called the opposite, and the opposite can also be called by another name, that is perpendicular. So understand this thing, that this side will be perpendicular opposite. BC in that case is the side adjacent to the angle theta, therefore we call it side adjacent, or we can call it the base as well, and side AC will be the hypotenuse. So when it comes to the calculation of sine theta, the sine theta is a trigonometrical function that is calculated by the perpendicular upon hypotenuse. Similarly, cos theta is calculated by the base over hypotenuse. The tan theta is calculated by the perpendicular over base. Cot theta is actually the reciprocal of tan theta, so this is calculated by base over perpendicular. Sec theta is the reciprocal of cos theta, so it is hypotenuse over base. And cosec theta is the reciprocal of sine theta, so that is hypotenuse over perpendicular. In the other terminology, if we were to write them, we can write perpendicular as opposite, so we can say opposite over hypotenuse, we can say adjacent over hypotenuse, we can say the perpendicular over base can also be written as opposite over adjacent, and now cot theta is the reciprocal, so it becomes adjacent over opposite, and sec theta is the reciprocal of cos theta, which is hypotenuse over adjacent, and the cosec theta is the reciprocal of sine theta, which is hypotenuse over opposite. Now, so this is how we can relate these trigonometrical function with the sides. Now, in the next few videos, we will also learn how to calculate the questions and some unknown in the question based on these trigonometrical relationship. But these are several things that we must know. So there are various ways that people learn these abbreviations. One of the ways is that if you can write it as PBP over HHB. So here P is representing perpendicular, B is representing base, P is representing perpendicular, and H is representing hypotenuse. On the other hand, you can also write it as opposite, adjacent, opposite divided by hypotenuse, hypotenuse, and base is same as adjacent. And you can quickly write various trigonometrical functions here. For example, we can write sine theta here. So sine theta is perpendicular over hypotenuse. Now cos theta is base over hypotenuse, tan theta is equal to perpendicular over base. And we have cot theta here, which is base over perpendicular, sec theta here, which is hypotenuse over base, and cosec theta, which is hypotenuse over perpendicular. And similar way, you can write the same abbreviations here as well. This is sine, cos, tan, cot, sec, cosec. So there are various ways people remember this. So either way, you can just remember this, but it's the most important part of this entire trigonometry, because the entire trigonometrical relationships will be built over these understandings, right? And at the same time, we can also just summarize quickly here on the other slide, and let me just quickly hide it, that if we have somewhere sine theta, then sine theta is same as 1 upon cosec theta. Similarly, cos theta is same as 1 over sec theta, and tan theta is equal to same as 1 over cosec theta. So these are another trigonometrical relationships which are quite frequently used, and for various questions these can be quite instrumental for us. So I hope it was beneficial. Thank you so much.